Hello, students. We are now on the last lesson in this unit. Topic of it is solving simultaneous equation using matrix method. So this is the last unit, last topic on the matrices unit. There's one other topic, but we are going to be doing that closer to the end. Now, at the end of this lesson, you're expected to answer all three focus questions. What are simultaneous equations? Some people pronounce it as simultaneous equations. And depending on the culture, instead of simultaneous equations, you might hear systems of equations. The second focus question is, how do we write simultaneous equation in the matrix format or method? And how do we solve simultaneous equations? So at the end, using the matrix method. So at the end of the lesson, we should be able to cover this. So at this time, I would like you to pause here, head up nicely with your topic and your focus questions, and then let's dive in to the lesson. So what are simultaneous equations? Now, you would have been introduced or be familiar with, some persons would have been introduced to simultaneous equation already. For those who have not, just let me give you a crash course. You are familiar with this equation, which we know as the referred to as the linear equation. All right, it look like the one at the top, or it might look something like this. And essentially, we are expected to solve the variable. In the first one, we expected to solve the y, and in the second one, we expected to solve the x. These are known as what we say linear equations. All right. Now, simultaneous equations now is a combination of two equations, okay? And not only are we combining two equations, we are combining two different variables in one equation. So here it says 4x plus 3y is equal to negative 13. And the equation below it says negative 10x minus 2y is equal to 5. So here we have two unknowns, and we have to find the values of both unknowns. And we're doing so together. All right, so that's the meaning of simultaneous, or simultaneous meaning to do things at the same time or simultaneously. All right, so essentially we have to solve both equations together to provide two sets of answers for each variable, the x and the y, and we are doing so at the same time. Let me introduce you now also to a real life example of the use of simultaneous equations, because it's essential. We can use it to find the unit cost or the unit price cost or the unit weight. And when we talk about unit, we are talking about the cost for one, or how much one thing is, how much one thing weigh. All right, if you're given information. So look at this information, this scenario. It says Pat and Jane stopped at a fruit stand. Pat bought 2 oranges and 3 mangoes for $82. Jane bought 4 similar oranges and 2 similar mangoes for $108. What is the cost of a mango, that is for 1 mango, and what is the cost of an orange, which is 1 orange? So in this case, here they're giving a statement that, hello, we're going to use our x and y. I'm going to use x to represent orange, and I'm going to use y to represent mango. And this is what it will look like as an equation. So the first part of the scenario says Pat bought 2 oranges, hence this 2x, because orange is represented by x, so 2 oranges would be represented as 2x, and 3 mangoes, 3y, and we're saying together those cost $82. We can eliminate the dollar sign for now until we are finished. And the second scenario, the second part of the scenario is captured below here, whereby it says 4 oranges was bought and 2 mangoes was bought, and both of them cost $108. Appreciate what is used for and in mathematics, which is a plus sign, and the result we normally put an equal to that result as you've seen here. Why not take a chance now to see if you can create simultaneous equation on your own given a scenario? So this is the one for you to try. I would like for you to pause, copy the question, and then you're going to try. But before you begin to create the simultaneous equation, I would like for you to extract out the statement and says, let lollipops equal to with the X or Y, and let toughies equal to X or Y, your choice. All right, so pause and copy that question and create your simultaneous equation on your own. All right, so what did you come up with? So let's say you used Y or X to represent lollipops, and let's say you used Y to represent toffees. All right. So your simultaneous equation will look something like this. It says 5 lollipops and 12 toffees. So you should have had this 5x if you used x for your lollipops. And instead of and, we're going to put plus 12 toffees. And we're saying that we are using y to represent our toffees. And that would be equal to 61 grams. And your next equation should look like this: 10 lollipops. So lollipops is represented by x. So it's going to be 10x plus 13 toffees. And both of them weigh 89 grams. We're saying with the correct method, you can basically solve them to find, in this case, the question that would have been asked, the question B that would have been asked would have been, what is the weight of one lollipop and what is the weight of one toffee? All right, but this exercise wasn't for you to solve it. This exercise was for you to learn how to create simultaneous equation from a worded problem. I'm hoping that this is clear. All right, so let's dive into the focus questions of this lesson. So I want you to appreciate that simultaneous equation can be solved in 3 different ways. So you should have solved them algebraically, but if not, that will be done later on. So it can be solved using algebra, it can be solved using graph, and they also can be solved using matrices. Obviously, this lesson will be teaching you how to solve simultaneous equation using matrices. All right, you can also take a note of this. So whenever you for note taking, you can pause the video and take your notes and then you dive in. I want you to note that this particular topic is one of the most important application of matrices. So far, we have learned how to add them, multiply them by a scalar. We have learned how to solve using equal matrix. We have learned how to find the determinant and the inverse. Do you know that all of those skills that you have learned will be tested when solving matrix method, solving simultaneous equation using the matrix method? So all of those skills are going to be incorporated in this particular objective. All right. So it's going to require all those skills, and that is why the lessons were built up to this basic point. So how do we solve them? So this is an important formula for you to write. Um, we solve them using this formula. A X, and it's a capital A, it's a capital X, and it's equal to B. All right? Essentially, what we are going to be actually changing out those simultaneous equations, and we are going to write them to look like matrices. I remember what matrices look like. They had brackets, they had numbers, and so on. So that's what is going to happen. All right. So when we have done so, like changing a simultaneous equation to a matrix, which I'm going to show you in the next slide, the A in the formula will represent a matrix of coefficients, and that matrix will normally be a 2 by 2 matrix. And what is the coefficient again? The coefficient is the number that's attached to the letter. So if I were to ask you, what are the coefficients in this equation? One of the coefficients will be this 2 because 2 is attached to the letter or the variable. And what about this one? We are not seeing a number in front, but we have known from our algebraic experience when we see a variable by itself, 1 is the coefficient. So 1 is actually attached to that y, even though it is not written. So be careful. So if I gave you 3x minus y, our coefficient for the first part will be minus 3, and the coefficient for this part will be negative 1. So coefficients are the numbers that is attached to the letter in this case. This 8 here is not a coefficient, it is called a constant. Okay, so just a reminder of those key words. So we're saying when we create matrices from our simultaneous equation, we are going to get one of the matrix to be a 2 by 2 matrix, and we use A to represent that. And then another matrix will be represented by B, and this matrix will be the solutions, will be the answers. And this matrix will usually be a 2 by 1 matrix. And lastly, we're going to have a matrix X, which is also a 2 by 1 matrix, and that will just contain the letter that you'll see in those simultaneous equations. More or less, you'll see X and Y, but you can use any letter. So based on the question, you're going to be using um, matrix X to represent the letters in the question. So essentially, when we are solving it, as we would have um, done for linear equation, remember I said to you when we started that we cannot divide matrices. Okay, we cannot divide them. Because if I'd given you a linear equation, let me just do a quick revision here. If you are given a linear equation, like 2x, let me get my pen. Let's say I gave you 2x is equal to 12, all right? And you want to find x. Your move would have been x is equal to, and because the 2 was multiplied by the x, you will have more or less divided by this 2 over here, which will give us 6. Since this is the formula for matrices, and we are going to try to find what x is, if it was algebra, you'd have told me x is equal to b divided by a. But we cannot do this for matrices. We cannot divide. We don't divide a matrix into another matrix. Remember we said B will be a 2 by 1 matrix and A will be a 2 by 2 matrix. We cannot do that. So what we do to show this in matrices, we use what we call the inverse of a matrix, which came from our last lesson. So we have to, for us to bring this A across, it's going to look like this below here. So this is also an essential thing for you to write. So from A is equal to B, you're going to write this. So essentially, this is what we are going to be doing. We are going to be to find X, which will represent the variable. We are going to we're going to find the inverse of this 2 by 2 matrix. And that is what we are going to use to multiply by the matrix B. Don't worry, as we go along, you will see how it is done. So please copy these two formula And I wrote it like this here because sometimes they give it to you like that. AX is equal to B, and you must know what it represents. And they may also give it to you like this, which is showing that you're solving for X here, which is what we are going to find we're doing for our simultaneous equation. So this is coming from that. So X is equal to A inverse times B. So pause again and write.